Everybody's eyes on me, please. Okay, we're gonna take like 5 minutes and play a vocab game. It's headbands. Have you ever played headbands? Okay, so what you do, if you haven't played, you're gonna play this. You're not gonna know what to do if you're not looking at me. Okay. When it's your turn, I'm gonna set a timer on my phone. Each person has 1 minute. You're gonna play in your table groups. When it's your turn, you hold this up to your forehead. They're a little small, but whatever. And then everyone else at your table has to give you hints as to what this says. When you guess, you go to the next one. Whoever at your table scores the most, of course, wins. Okay?
And then 1 minute?
In 1 minute, and then you switch to the next person. Okay? Maybe mix them up between each person. You can decide who goes first. Here's the thing. You can use, are you listening? You can describe in English or Spanish.
Heterozygous.
Heterozygous? Capital T, lowercase t.
Yes. Homozygous
Homozygous recessive?
Yeah.
Little t, little t.
Yes. Homozygous.
Dominant. Big
Yeah.
T, big T.
Yes. Genetic makeup.
Genotype.
Yeah. Physical appearance.
Phenotype.
Yes.
Yes! Okay, 2, 3, 4, 7. How many?
7.
And table 5?
8.
All right, so who won? 19, 15, 19, 8, 19.
Can we do it?
Can you whisper?
They can't whisper. I don't believe it.
Whisper. Change me. Okay, was that fun? All right, if you keep my cards, then I'll add some new ones in as we get more terms. Maybe we'll play.
Who keeps them?
All right. I have your notebook. So. You haven't done
I had 7.
I had
5.
We're gonna do more than one. All right. If you finished your genotype and phenotype from yesterday, you want a different one, okay? Just gonna do a couple more practices before we start working on that. Can I have everybody's attention?
Fine.
I think we need to review as a class.
Who says this?
All right. Where's my eraser? Okay, as a class. Who has number 1? Raise your hand if you have number 1. Okay. Yellow seeds are dominant over green seeds, so I'm going to write. Little y is green. Okay. Fill in the Punnett square. Here's my Punnett square. and determine the expected genotypic and phenotypic ratios from crossing homozygous recessive. What is that going to be? Homozygous recessive. Everybody. Homo means same. Recessive means small letter. So we're going to have two little y's, right? And homozygous dominant. Homo means same, and dominant means capital. All right. Big Y's come over. Little Y's come down. What are my phenotypes? Phenotype, remember, PH for physical. Physical appearance. What do they look like? What is the trait that's showing? Yellow. Okay. What is my percentage of yellow? 100% yellow. What is my genotype? Capital Y. And what's the percentage? 100%. Now that one was pretty straightforward because all of them were exactly the same. Okay? Who's got one that's got two heterozygous parents? Which one is that? Number 5? Okay. Let's do number 5. Number 5. It's talking about tall pea plants, right? So tall is dominant, right? So we're going to make that big T. And short is recessive, so we're going to make that little t. Draw our Punnett square. This marker's going out on me. Let's see if this one stays. Okay. All right. So we have two heterozygous dominant parents. We know that heterozygous is always going to show the dominant trait, right? So it's kind of redundant. But we're going to put one of them here. Heterozygous means different, so we should have big T and little t, right? Bring these big T's over. And then bring these T's down. Remember that you always have to start, so I'm just bringing it down that way. And then the little t comes over, and then we have two T's. All right. How many different genotypes do we have here? We have 3, right? So under genotypes, you should be writing TT, TT, and that TT. What is our percentage of homozygous dominant? What is it? 25%. What is our percentage of, or probability of a heterozygous dominant? Okay. And for homozygous recessive? 25. Okay. Now, what is our phenotypes? What phenotypes are present? Tall and short. Okay. Tall, short. What is our probability of having a tall plant? 75%. Good. And what is our probability of having a short plant? Okay. Does that kind of clear up what we're looking for, what your answers should look like?
No.
No? You still haven't, which one do you have?
6.
Number 6. All right, let's do number 6. Okay. All right, read me number 6.
The axial flower position is dominant over the terminal flower position. Fill in the Punnett score and determine the expected genotypic and phenotypic ratios from crossing heterozygous and homozygous dominant.
So it's talking about things that we don't really know about, right? But we can still do the problem. So axial is dominant, we're going to give it a big A. The terminal is recessive, so we're going to give it a little a. Draw our Punnett square. Note to self, get new expo markers. Okay, and we have the heterozygous and a, is that what good? I know, it's like when they seem good and then they trick me. Liars. Okay, we have heterozygous. Is that right for heterozygous? Okay, and then we have homozygous dominant. So what would that be? Capital or lowercase? Okay. All right. Where does this go? Where does this go? And this one? And this one? Okay, so let's start by talking just about the alleles for the genotype, right? What are our possibilities? We have homozygous dominant, right? We have heterozygous. Do we have any other possibilities?
No.
Okay, so what is our probability of getting homozygous dominant? 50%, okay? And our probability of getting heterozygous? Okay, now let's talk about the phenotypes. We know that big A is dominant. We don't really know what axial is, but we can pretend that we do. Okay, what is our probability of having axial? 50? 100%. Because if it's heterozygous, the dominant gene is going to take over, right? How are we doing? Is it starting to make a little more sense? We're going to be doing this when we do our pets. Yes?
In a breed, it has two homozygous parents and homozygous.
So both sets of parents are homozygous then, so you should be using all what? Well, they're homozygous recessive. So you'll have 4 lowercase. So what should all of your babies be? They'll all be homozygous recessive, right? Because that's all that's present. That's the only possibility. Okay, so you should have like 100% for both. Okay. All right, y'all want to work on them some more? Yes. Trade with someone, and if you finish your problem, trade with someone. Let's practice this again. You got a really easy one? You can also just look up with someone else that you find what other times. They wrote on them, and I did I know sometimes these terms but just ignore that and do what you can do, because you could just, I know, it's tricky.
Can we get a sense? Because like we don't have anything to teach.
Yeah, you can switch with somebody. Which one do you have? Number 8?
You got that?
Okay, so he's almost done with that one. And then what's this one over here? No, this is number 8. Why don't you look over Zoe for a minute? Okay, number 7. Here's some number 8s. Have you done number 8? Did you finish number 6? Here, try number 8. What? Here, try number 6. Have you done number 8? Have you done number 6? You just did 8 and 6. That's all I have. You haven't done 8. Come look on with Isabella, because she's got number 2. We're trying to do extra problems. Does anybody need number 8 or number 6? No, Dominic. How are you doing? Usually like getting everything, so you're having trouble. So you could do 1 to 2 to 1 or in terms of percentages instead of like ratio.
Because you didn't want to change, so.
Marty, I had all the
I need to get one.
So the probability, you have to talk about what the probability of getting each type of change is. So what's the probability of getting?
Here you can't tell which is a small
And
pin.
then we're getting. So that's usually Somebody need 6 or 8? Yeah, well, you've already done both of these. He's got number 3. So that's what I saw before. Okay, so that's the ratio. So what is your genotype going to be? You've got 2 different possibilities here, right? You've got homozygous dominant and heterozygous. And then your phenotype, they're all going to be the same, right? What is the phenotype? You're dealing with tall probability. So all your plants are going to be tall. So you have a 100% chance of being tall, right? But only a 50% chance of having this your genotype and this your phenotype. I get 10. So you go work on this
You two are dominant, that's why you can hide. So, like,
Yeah.
sorry. But you need to change yours. What? Your own
It's a combination of the two.
I wish it was still. That's
Yeah. And even though they do it,
Yeah.
We have to look together.
How are we doing? I have number 1. Feel like you got it? Yeah, just if someone's having trouble with it. Why don't you walk around and see if anyone's having trouble with 6, 8, or 3?
Who has 3? I mean, who has 8?
I already did 8. Already did 8. Then there's your mouse. Hey, oh my goodness, feel it. And I'm like,
Okay, there's more. Or your notebooks are back.
How many should we do? How much should we do? 3?
I have 1 and 6.
Okay.
If you have finished, then you need to do this for your pet. Okay? You need to make sure that your pet, you have his phenotype and his genotype. Okay?